Okay, in this part of the video, we are going to discuss about the third, not the third, the second part, second technique of integration method, which is integration by parts. Okay, kalau tadi kita dah settle dah with substitution method. Now let's find out what is actually integration by parts. Alright, so kalau yang integration by parts ni is a technique for simplifying integrals of the form fx times gx dx. Kalau yang substitution method tadi, kita banyak try to solve when the function is multiplied, but when two function, one of the function is a composite function, kan? Kita ada, kalau yang substitution method tadi, f g prime x, fgx times with g prime x dx, macam tu kan, yang kita let u tu. So yang ni integration by parts is multiplication of two function f as gs, where one of the function can be differentiate repeatedly. Maksud repeatedly ni, yang function tu yang dia tak akan habis. You integrate, kalau macam function x power of 5 dx, then the kuasa tu dia akan increase kan, x power 6 over 6. Later kalau integrate lagi, dia jadi x power 7 over 7 and so on and so forth. But this function where you integrate, dia dapat macam contoh dia saya bagi cos x dx. You integrate cos x, you dapat sin x, betul? Then you integrate balik sin x, you dapat balik cos x. So maknanya p my, orang kata apa? P my tentu. Okay, within the circle. Satu lagi contoh is e to the power of x. You integrate e to the power of x, you won't get anything else. You will get back e to the power of x. Integrate balik, you akan dapat e to the power of x. So it's repeatedly. Okay, without difficulty, tak susah pun kan. Alright, so let's have a look further. Ni antara contoh soalan yang we may solve using integration by parts. Okay, because we have cos x, x ni tak apalah, simple. We have cos x dx ni sepatutnya dekat ni, and then we have x square e to the power of x dx. Okay, now next, okay, cuba kita tengok dia punya formula. Okay, dia punya formula. Actually, to make the story short, ni formula dia. Integration of uv equals to uv minus integration of v du. Makna kata, the function that we have, dia punya derivation is this one. Okay, d dx of, dia bermula daripada product rule sebenarnya. Product rule of differentiation. Ingat tak, product rule kan kita ada multiplication of two function fgx, then we have f x g prime x plus g x f prime x, right? So if we apply integration to both side of this, okay, kita akan cancel lah. Antiderivative of derivative tak adalah ni, gone. So we have fx gx is equals to this one. Okay. Then dari sini, okay, we have fg prime x dx is equals to, okay, fx gx minus with gx f prime x. Maknanya saya susun balik integration ni. We bring this one fx g prime x dx to your left hand side, okay, and then sorry, bukan yang ni bring to the left hand side. Apa ni? Silap ni. Sebenarnya tak ada apa pun. Apa ni? Yang ni. This part, okay, fgx f prime x ni, yang ni kita remain lah kat sini. Okay, remain kat sini fgx g prime x dx ni dia duduk sorang-sorang. Gx f prime x ni pergi ke belah sini. So dia jadilah fx gx tolak gx f prime x dx. Okay, so bla bla ni dari sini kita keluarlah sebenarnya formula yang ni. So I don't want to spend much on the derivation sebenarnya, just to let you know this actually coming from product rule dalam differentiation itself. Okay, so the formula is integration of u dv equals to uv minus integration of v du. So apa benda ni, it will be much clear if we look through examples. Okay, so have a look at this example. We have example 9 here. Okay, integration of x cos x dx. Okay, integration of x times with cos x dx. So kalau you tengok, we have two function, multiplication of two function here to solve the integration. Okay, so kalau kita try direct integration, of course tak boleh nak main integrate x, integrate cos x. No, bukan cara dia. Okay, and then yang ni, kalau kita nak guna substitution method, I don't think it will solve the problem. Okay, dia akan remain. Dia nanti kalau you try, dia akan jadi u cos u macam tu je sampai sudah tak solve. Alright. So the option that we have, you may use integration by parts. Okay, sinonim integration by part ni lebih kurang macam product rule lah dalam differentiation ya. Okay, so you may use this formula uv minus integration of v du. Okay, so all you need to do is you have to determine apa yang you nak let as your u and what is you want to let as your dv. Kalau sebelum ni substitution method, kita just let u kan. Okay, what you want to let as your u and what is your dv. Okay, so daripada situ okay, daripada sini kita ada few options. Okay, what to let your u as your u or dv. Okay, you can yang pastinya you have to make sure bila you let u and dv here, u times dv dia akan equivalent to whatever that you have inside the integration here. Okay, so maknanya u times dv for this case example 9 should equals to x cos x dx. Semua ni. Okay, tak boleh ada pun yang tertinggal. Okay, so here are the options that we can choose. Okay, we let u equals to 1. Then kalau let u equals to 1, maknanya the rest, the remaining will become dv x cos x dx. Yang ni tak ada makna lah. It will be the same as the function that we have been trying, macam soalan je. Okay, and then we have let u equals to x. Then dv equals to cos x dx. One option. Another option is let u equals to x cos x. Then dv is equals to dx. Ataupun we have let u equals to cos x and then dv equals to x dx. Okay, so which one should we choose? Okay, which one that we should choose? Okay, so dia punya priority sebenarnya untuk you choose u. Okay, kita ada priority. Kalau lah dalam function tu ada logarithmic, okay, then you better choose logarithmic become your u. Then the remaining will be your dv. Okay, dv is the leftover part. Okay, and then or if you have the inverse trigonometric function, sine inverse x, cos inverse x and so on, or if you have algebraic function, okay, maknanya yang paling priority kalau ada algebraic function, then we let u to equals to algebraic function. And then if we have trigo function, maknanya sekarang ni kalau ada algebra and trigo, kita akan let u to equals to algebra because the priority untuk algebra is higher than trigonometric function. Then last yang bawahnya exponential. Kalau ada exponential, we choose exponential provided dalam tu tak ada algebra ataupun trigonometric function. Kalau tak, kita akan pilih diorang dulu sebab the highest priority is the algebra function, then followed by trigonometric function, then exponential function. Alright? Okay. So daripada rule tadi ni, okay, daripada rule number 2, back to our example 9, we have x cos x dx. So which one will we choose? Option number 1, number 2, number 3 or number 4? See, kita ada first function category algebra function. Second one is category trigonometric function. So what shall we let as your u? Which function shall we let as your u here? Okay, kalau kita tengok Ni logarithmic tak ada, inverse tak ada. Yes, we do have algebra which is x. So maknanya the highest priority for us to choose here, let u equals to x. Then the remaining will become your dv. Then meaning that for this case, your dv is equals to cos x dx. Okay, cos x dx. So we're going to choose number 2. Okay, now let's try to solve the rest of the solution. Okay, we have u equals to x and dv is equals to cos x dx. So kalau you multiply u dv, nampak tak? It will equivalent to whatever that we have in the question tadi. So done with the first step, we let u equals to x, dv equals to cos x dx. And from here, what we're going to do with u ni kita akan differentiate respect to x. So du over dx is equals to 1. And v kita akan integrate. Okay, we are going to integrate v. dv tu kita akan integrate, kita dapat v. So v is equals to integration of cos x dx. So integrate cos x, what you will get is going to be equals to sin x. Okay, so according to the formula, kita ada integration of x cos x dx equals to u dv. So this is equals to uv minus with integration of v du, right? So uv, what is our u? U is x times with v is sin x. Okay, uv, okay, u and v here at sin x minus with integration of v, again v here, which is sin x. And for this case, our du is equals to dx. Okay, then can you see this? We have at sin x minus with integration of sin x is negative cos x. Dan barulah kita tambah c kat sini. Kat sini kita tak tambah c lagi. For this integration no need c. Okay, no need c. So meaning to say the final answer for this is x sin x plus with cos x plus c. Right? Okay, so we're done with example 9. Okay, so now let's proceed to example 10a. We have ln x times with dx. Ln x times with dx. So makna kata how many function do we have here? Kita tak nampak. Sebenarnya we have 1 darab dengan ln x dx. Okay, 1 darab dengan ln x dx. So if we look into the priority, okay, nampak tak? The first in the list is the logarithmic function to choose as u. So definitely for this one, okay, we're gonna choose u equals to ln x. Then what we have? We have dv equals to 1 darab dengan dx, ataupun you boleh tulis dx sajalah. So daripada sini, let's proceed. U kita buat apa? We differentiate du over dx is equals to 1 over x. And then dv dx we integrate 1 darab dengan dx. Okay, integrate 1 we will get x. Then use the formula uv minus with integration of v du. We have uv, this is our v, u and v, we have x ln x minus with integration v is x, and then our du. Okay, for this case our du is equals to apa? Du is equals to dx over x, kan? Okay, du is equals to dx over x. Then you can cancel this one and this one. So you have 1 integrate with dx. So x ln x, integrate 1 respect to dx, you get x, kan? Okay, then plus with c. That's it. Okay, so that is the answer for A. Okay, the answer for A. Now let's try for B. Okay, untuk B ni, the function is integration of x square e to the power of x dx. Okay, kita ada algebra function, okay, polynomial function here. E to the power of x is exponential function, okay, exponential function. So remember, exponential function is apa ni yang paling on the bottom of the list. Okay, so in this case maksudnya kita akan let u equals to as x square dv is equals to e to the power of x dx. So from here we have du is equals to 2x dx. Okay, du over dx is equals to 2x, so that's why du is equals to 2x dx. And then v, integrate v, e to the power of x dx, we get back e to the power of x lah. Okay, right, we get back e to the power of x, but dia punya power ni hanyalah x. Okay, alright, so from here we have the integration x square e to the power of x dx is equals to uv minus the integration of v du. So here uv is equals to x square e to the power of x minus the integration of v. V is d e to the power of x, du is equals to 2x dx. So saya letak kat sini x square e to the power of x minus with 2 is a constant kan, you may bring it out, integration of x e to the power of x dx. Nampak tak? Is it gonna solve the problem? Not yet. Kita masih lagi ada this part. Okay, we still have this part. Okay, so how we gonna solve this integration? So maknanya kat sini you have to apply again integration by part. Okay, you have to solve separately first x e to the power of x dx. Okay, so for this case again you let u equals to x and then dv equals to e to the power of x dx. Okay, so daripada sini kita akan dapat again du equals to dx and then v equals to e to the power of x. Okay, so for this case kalau guna formula kita akan dapat uv minus the integration v du. uv is x e to the power of x minus the integration v e to the power of x dx. Yang ni ada masalah tak? Integrate e to the power of x, no more problem. You integrate e to the power of x, you will get e to the power of x back kan. So we have x e to the power of x minus with e to the power of x. Okay, so finally kita boleh dah lah substitute kat sini. So maknanya the answer for this one is x square e to the power of x minus with 2 integration of what you have just now, x e to the power of x minus e to the power of x, and do not forget plus with c. Okay, plus with c the whole part lah. Okay, so this is the final answer for B. Okay, untuk C I think I'll keep it untuk C ni saya akan save untuk our synchronous lecture on Wednesday. Okay, sebab dia punya teknik ni special sikit. Untuk D, I want you to solve. Okay, untuk D, I want you to solve. Tapi, I provide you with the final answer for D. For D, final answer dia is 1 minus with 5e to the power of negative 4. Okay, tapi I want you to, satulah saya nak bagi hint dekat you to integrate e to the power of negative x dx. Okay, e to the power of negative x dx. Kalau kita integrate e to the power of x dx, kita akan dapat e to the power of x balik, betul? Okay, because this one is actually x ni, kita differentiate x, you dapat 1. Actually, we divide by 1. Okay, so yang ni sebenarnya e to the power of negative x divide by the derivative of the power. So derivative of the power negative x with respect to x, you get negative 1. So maknanya integrate this, you get negative e to the power of negative x. Okay, Sama juga kalau ada soalan tu integration of e the power of 3x dx. So what you will get is e the power of 3x over 3. The power tu we differentiate, kita bahagi. Okay. Actually you can solve this using substitution method. Ni shortcut. Okay. Instead of using substitution method, guna ni kita akan dapat e the power of 3x over 3. Sebab kalau kita differentiate d dx of e the power of 3x, apa kita buat? Okay, kita differentiate e to the power of 3x, copy balik soalan dan darab dengan the derivative of the power, right? So if we differentiate, we get 3 times we e to the power of 3x. Tapi kalau kita integrate, kita bahagi. So we get e to the power of 3x over 3. So that's why yang ni lah. Okay, we get negative of e to the power of negative x. Alright, so this is a hint for you to solve D, where you should get the final answer equals to 1 minus 5 e to the power of negative 4. So meaning there are 2 classwork submission for today's synchronous lecture. One from the substitution method and another one is this question D. Okay, I'll provide you also the final answer. Okay, so that's all for today's synchronous lecture.